Hi friends, once again welcome back in our educational channel, that is FYJC Electronics. Friends, in today's video lecture we are going to study the concept of energy, the types of energy, sources of energy, and the Einstein equation, that is E is equal to mc square. In previous video lecture we had studied atomic structure, Ohm's law, and the band theory of elements. And in this lecture we are going to study energy. Friends, what is energy? Energy is the capacity of physical system to perform work, to do work. That is energy. It is also states that the ability of that system to do work or to perform the particular work, that is energy. Energy is available in various forms, and some of the famous forms are: first, that is thermal energy, heat energy, or that is thermal energy. The second type of energy available is energy provided by the light, that is known as a radiation. Light energy, radiation energy. The third type of energy, that is motion, that is known as kinetic energy. Energy provided by a moving object is known as kinetic energy. The next type of energy available in electrical form, the electricity is used to perform the various types of work. So that is because of the electric energy we can able to perform the various tasks. So electrical energy is one of the form widely used in daily lives. The next type of energy, the next form of energy is chemical energy. The chemical reactions gives a lot of energies. So chemical energy. Nuclear energy is one of the form of energy which is widely used to generate the electricity. So nuclear energy. And last but not least, that is gravitational energy. The gravitational force. That force gives some energy. Because of that energy, we are able to perform some work. That is gravitational energy. These are the form of energy, the various forms of energy. Now we are moving towards the sources of energy. Energy sources is mostly divided into two types. So there are two types of energy sources. There are two groups of energy sources. The first type is renewable energy. Renewable means an energy source that can be easily reused. Means we can reuse that energy source. That is known as a renewable energy. And there are 5 main renewable energy sources. Do you know the types of energy sources, that is renewable energy sources? Yes, first, that is solar energy. That is available because of sun. The solar energy from the sun is the first type of renewable energy. The second type of renewable energy is geothermal energy. That is because of heat inside the earth. That energy is known as a geothermal. Thermal means heat, geo means our earth. So geothermal energy is the second type of renewable energy. Next type of renewable energy is wind energy. Wind energy is also renewable energy. Next, biomass of plants. Biomass of plant is one of the renewable source. And the last type is hydropower from flowing waters. The turbines rotate because of that force created by that water which is applied on that turbine with a very high speed. That energy or that source is one of the renewable source, that is a hydropower from flowing waters. So friend, these are the sources of renewable energy. The next type of energy is obviously it is a non-renewable energy. Renewable and non-renewable. An energy source that cannot be easily replenished. म्हणजे ती आपल्याला काय करता येते, परत परत यूज करता येत नाही. An energy source that cannot be easily replenished. That energy source is known as a non-renewable energy. The types or the sources of non-renewable energy. The first type is petroleum products. Means petrol, diesel, kerosenes, then charcoals, etc. Mostly the petrol, diesel and kerosenes are the sources, are the subtypes of petroleum products. These products are used to generate the energy. For example, in vehicles, the petrol is used or diesel is used. So first type, that is a petroleum product that produce the energy, which is known as non-renewable energy. Second type, that is a hydrocarbon gas liquids. Means our LPG gas cylinders. That hydrocarbon gas liquids also a subtype of non-renewable energy. The next type is a natural gas. In our motors, the LPG or CNG may be used, or a cooking gas, that is an example of natural gas. The next, the coal, charcoal, the coal is used in electric, is used to generate the electricity. That is a coal. The thermal power plants uses the coal. So coal is one of the non-renewable energy source. And nuclear energy. So these are the examples of non-renewable energy source. That is petroleum products, hydrocarbon gas liquids, then natural gas, coal, etc. are the sources of non-renewable energy. Now we are moving toward the types of energy. Basically, there are two types of energy. The first type, that is a stored energy, and that is known as potential energy. What is potential energy? Potential energy is mostly symbolized by capital U. It is symbolized by capital U. This energy is stored in a system. Suppose this is a pen. It is kept on a height. This pen stored energy, but this energy is in form of stored form. So this energy is known as potential energy, or it is a stationarily charged particle in an electric field produces a potential energy. A stationary object in a gravitational field or a stationarily charged particles in an electric field produces the potential energy. The second type of energy, that is working energy, and obviously it is known as kinetic energy. Working or kinetic energy. What is kinetic energy? The kinetic energy is observed as a motion of an object. Suppose this is a pen which stores the energy in form of potential energy. If this pen, when I am going to release this pen generates the energy that is known as kinetic energy. So that is kinetic energy. Example, that is including the falling of an object in a gravitational field. Falling of an object in a gravitational field, that generates the kinetic energy. Or the motion of charged particle in an electric field. When electric field, the supply, the battery potential is applied, the electrons try to move from one place to another place. So current conduction takes place, and when the current flows, the kinetic energy will be generated. The stored energy is converted to kinetic energy. Moving object or the falling of an object in gravitational field, that generates the kinetic energy. The common symbol of energy is E. It is given by capital letter E. A standard unit of energy is obviously joule. Joule, J. It is symbolized by capital J. And this joule or the capital J is honor of James Prescott Joule, the name of the scientist, that James Prescott Joule. On the honor of this scientist, the symbol J is used and the unit joule is used for the energy. In electrical circuits, energy is a measure of power expended over the time. How much power is used within the particular time, that is a energy. In electrical circuit, the energy is measure of power expended over time. In this sense, 1 joule. What is 1 joule? 1 joule is an equivalent to 1 watt. Power is measured in watt. So when 1 watt power is dissipated or it is radiated in 1 second, then the energy of that instrument, energy of that device is 1 joule. So friends, what is 1 joule? 1 joule is equivalent to 1 watt power that is dissipated or radiated for 1 second. A common unit of energy in electrical utilities is kilowatt hour. Mostly the energy measured in kilowatt hours, which is equivalent of 1 kilowatt dissipated or expended. That means it is used for 1 hour, because 1 kilowatt is equal to, obviously K means 1000, so 1 kilowatt is equal to 1000 watt, and 1 hour is equal to 3600 second. 1 hour means 60 seconds. 60 minutes, sorry, 1 hour means 60 minutes and 1 minute means 60 seconds. So 1 hour is equal to 3600 second. Therefore, what is 1 kilowatt? 1 kilowatt is equal to 3.6 into 10 raised to 6 joule. So the power consumed by our electric appliances is measured in kilowatt hours. How many power is used, that is given in kilowatt hours, or 1 kilowatt is equal to 3.6 into 10 raised to 6 joule. Now we are moving toward the main part of the energy, that is conservation of energy. Conservation of energy. What is conservation of energy? The energy can neither be created nor be destroyed. That means we are not able to create the energy, or we are not able to destroy the energy. So energy can neither be created nor destroyed, and this law is known as law of conservation of energy. Means आपण एनर्जी जनरेट पण करत नाही आहोत, म्हणजे तयार पण करत नाही, की एनर्जी आपण संपत पण नाही आहोत. मीन्स वी आर गोइंग टू कन्वर्ट वन फॉर्म ऑफ एनर्जी इनटू अनदर फॉर्म. फॉर एक्झाम्पल, when we are going to switch on the light bulb or LEDs, the electric energy is converted into light energy. So one form of energy is converted into another form. This law, we can conclude that, by using this law we can conclude that the total inflow of energy into a system, suppose this is a system, suppose this is a system, energy applied to this system, that is the inflow of energy, and the energy delivered, the outflow of energy, the work performed by that device, that energy must be same. So energy can neither be created or not destroyed. This law is known as law of conservation of energy. Next, mass and energy equivalence. What is the relation between mass and energy? This mass and energy equivalent, or that relation, is known as Einstein's relation, Einstein equation. This equation or this equivalence states that anything having mass has an equal amount of energy. Means, suppose this pen has a mass, so obviously this pen has equivalent amount of energy. That means anything having mass has an equivalent amount of energy, and obviously the vice versa. That means with these fundamental quantities directly related to Einstein's equation, Albert Einstein equation, Albert Einstein formula, and this formula is very famous, that is Einstein formula or Einstein equation. What is that formula? That is E is equal to mc square. E is equal to mc square. What is E? Obviously E is energy. What is m? That is mass of that element, and c, that is speed of light. Now E, that is energy, which is measured in, obviously, joules. Mass, that is measured in kilogram, and c, that is a speed of light, and speed is always measured in meters per second, and the value of c is a constant, and it is 2.99792 into 10 raised to 8 meter per second. but mostly for practical purpose it is considered as 3 into 10 raised to 8 meter per second. That equation E is equal to mc square. This revolutionary, हे जे इक्वेशन आहे मित्रांनो, या इक्वेशन मुळे काय झालं, द फर्स्ट ॲटम बॉम्ब इज क्रिएटेड. E is equal to mc square. This revolutionary scientific paper was published by Albert Einstein in 1905, and Albert Einstein received the Nobel Prize in Physics in 1925. This equation is E is equal to mc square. E for energy, m that is a mass. Every element which has mass has an equal amount of energy, and E is equal to mc square. See, that is the speed of light. So friends, that is the energy. And in this lecture we had studied the types of energy, the sources of energy, the form of energy, and the Einstein equation, as well as the law of conservation of energy. In next video lecture we are going to study the power of a system, the power of that element, and we are going to study the Joule's law. So friends, keep watching these video lectures. Bye, take care, see you again in our next lecture. Bye, goodbye.